Hello everyone. On this video we will look at a few practical story problems using the multiplication of fractions and mixed numbers. Alright, and for most of these I'm going to draw a picture to accompany it just because sometimes it helps to draw a picture to visualize exactly what you're solving for. Alright, so for our first example it says shingles are laid so that 5 inches can be represented as 5/12 of a foot, is exposed in each layer. How many feet of the roof can be covered by 28 courses? Alright, so what I want you to do is press pause and solve that one on your own. Alright, so I'm assuming you've pressed pause and you're all done solving this one. So let's go ahead and solve it and verify your answer. Okay, so I'm going to draw a picture of a shingle. Let's say this is your 5/12. This entire section here is 5/12 of an inch. Okay, that means we have 28 courses, so we have 28 of those. So that means we are looking for 5/12 times 28, which we can rewrite as 5/12 times 28/1. All right, so remember, we just multiply across, and I'm going to put that below because I think I might run out of room over here. So you have 5 times 28/12 times 1. Okay, so we know that our 28 is 7 times 4, and our 12 is 4 times 3. So that's 5 times 28, so instead of 28, we put 5 times 7 times 4. Over, instead of 12 times 1, we just put 4 times 3 times 1. All right, we can see here 4 in our numerator and denominator cancels out. So that leaves us with 5 times 7 times 1, or just 5 times 7, which is 35, over 1 times 3 times 1 is just 3. Which, if we put that into a mixed number, it becomes 11 2/3 feet that will end up being covered by 28 courses. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to the next example. Clicker here. Okay, so you want to find the total length of 12 pieces of wire, each 9 3/16 of an inch long. All right, so what I want you to do, once again, is go ahead and press pause and try to solve this one on your own. All right, so assuming that you have already pressed pause and solved this one, we're going to go ahead and verify your answer. Okay, so if we have a wire that's 9 3/16 inch long, I'll say that's my wire. And it's 9 3/16 inch long. But it's also equal to 147/16 if you convert it to an improper fraction. Okay, so we need 12 of those, which means we'd get this length multiplied by 12. So we have our 9 3/16 times 12, which is equal to, since we converted to an improper fraction, 147/16 times, and instead of 12, we're going to make that 12/1. Right, so again, if you look here, if you do the 147 times 12, that's going to become a very big number, and trying to simplify it is going to be a little bit tougher. So if we have our 147 times 12/16 times 1, remember that 12 is 4 times 3. And that 16 is 4 times 4. Okay, so that's going to equal 147 instead of times 12 times 4 times 3. And instead of 16, we have 4 times 4 times 1. And the 1 you don't have to put there, but I put it there anyway. Okay, so we see here we have a 4 here and a 4 here that cancels out. Doesn't matter which 4 you cancel out, and they become 1. So you end up with 147 times 3, which is a lot easier to deal with than 147 times 12. Okay, so 147 times 3 over 1 times 4 times 1, which is just 4. So we end up with 441/4, which is 1/10 1/4 inch. If we convert it to a mixed number. All right. So if you're still writing, by all means, feel free to press pause. We're going to go ahead and move on to our next example. Okay, so for this question, it asks, how far will a nut advance if it is given 18 turns on a 1/4 inch 24 NF, which is the National Fine Thread bolt? Let me move this here. There we go. Okay, now note, a 24 NF designation means that the nut advances 1/24 of an inch for each complete turn. All right, so once again, I want you to go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and you're all done. So let's go ahead once again and verify your answer. Okay, so of course your pictures don't have to be perfect. You just need to have something to help you visualize. Okay, so what if this is our bolt? This whole thing is our 1/4 inch bolt. And this represents 1/24 of the 1/24 of an inch. All right, so if we know this is 1/24 of an inch, which represent a complete turn, how high up on that bolt will we get if we turn that 18 times? Okay, so that means we have 1/24 times 18 turns, or just 1/24 times 18. All right, so we know that 18, we can rewrite that. That's 1/24 times 18 over 1, which will become 1 times 18 over 24 times 1. All right, just like before, we want to simplify it ahead of time. We can. Just remember that 18 is, well, instead of 9 times 2, let's do 3 times 6, and I'll show you why. And the 24 is 6 times 4. Now, if I did 9 times 2, there's no 9 here that would cancel out. You can cancel out a 3. But there's also a 6 that could cancel out. Okay, so here I went ahead and picked the 3 times 6 because I knew a 6 would appear down here. All right, so instead of 1 times 18, you have 1 times 3 times 6. And instead of 24 times 1, you have 6 times 4 times 1. Well, you don't really need the 1s there, but they're there anyway. Okay, so this 6 and this 6 cancels out and becomes 1. So you have 1 times 3 times 1, which is 3, over 1 times 4 times 1, which is 4. So if you know 1 complete turn gives you 1/24 of an inch, if you give it 18 complete turns, you will be up 3/4 of an inch. All right. So if you are, once again, still writing, feel free to press pause. But we're going to go ahead and move on to our last example. All right, so it says, what is the volume of a rectangular box with interior dimensions 12 1/2 inches long, 8 1/8 inch wide, and 4 1/4 inch, oh, it's deep. I don't know why I put deed. Deep. Hint, volume is equal to length times the width times the height. So, once again, I want you to press pause and go ahead and try to solve this one on your own. All right, so assuming you're all done, so let's go ahead and verify your answers. All right, so just to draw a picture, hopefully I'll get my box drawing correct on the first try. Not bad. I've done worse. Okay, we'll say that's the top. And shade in the bottom there. There we go. Okay, so we have our width. And we have our length. And we have our height. Okay, so volume is equal to length times width times height. Well, the volume of a rectangular box. And that means our volume is equal to 12 1/2 inch times 8 1/8 of an inch times 4 1/4 of an inch. Okay, so that will be, if we wanted to, we could take our inch unit of measures, because this would be 12 1/2 times 1 inch times 8 1/8 times 1 inch. So we can get all of our inch units of measure and move them over to the right. So we have 12 1/2 times 8 1/8 times 4 1/4 times 1 inch times 1 inch times 1 inch. So all we did was get our units of measure and move them over there just to kind of get them out the way. All right, so we're going to go ahead and first convert these to improper fractions. 2 times 12 is 24, plus 1 is 25. So you have 25 over 2 times 8 times 8 is 64, plus 1 is 65. So you have 65 over 8 times 4 times 4 is 16, plus 1 is 17. So you have 17 over 4 times inch times inch times inch is cubic inches. So I'll just write cubic inches or inches cubed. And we'll just move that down as we proceed. Okay, so this part of it will just become 25 times 65 times 17 all over 2 times 8 times 4. Now, unfortunately with this one cannot be simplified any more than this, because if you make this 5 times 5 or you factor out the 65, it will cancel out with nothing on the bottom. So you just have to go ahead and multiply this. So you end up with 27,625 over 64, which is equal to 431 and 41/64 cubic inch. Okay, so just a note that inches cubed is the same as saying cubic inches. All right. So hopefully this made sense and gave you a little bit of an idea on how to approach story problems or your problems that may involve multiplication of fractions and mixed numbers. Hopefully it helped, and I will see you on the next video.